to our math homeschool connection night. The only one for November because it's a weird month with Thanksgiving in the middle. Tonight we're going to be reviewing the first advisory benchmark and talking about geometry, which normally I try to have these homeschool connection nights before we start that unit, but just with the way the last month laid and this one, we kind of are in the process of our geometry unit. Actually, tonight's video is the last part of the geometry unit. Not to say we're done with it in class, but you're kind of learning at the same time that the kids are. So, always thank you for coming. I really do appreciate you giving up an hour of your evening. I know this isn't the most ideal way to spend your evening, but I appreciate you coming. It'll help you review different math tests, different skills, getting them ready for other opportunities. And this one is on my website, because you're watching it on my website right now. And we can always talk about your specific child afterwards. So we're going to start with a pop quiz. If you turn to the very back of your packet, there are 5 questions for you, 5 math questions for you to answer. I thought of you spelling. Oh, my bad. So just take about 5 to 10 minutes to solve those problems, and then we'll give you that. If you're watching at home, I'll share this out. we're, for the most part, finished there. All right, so to go over these, and we'll talk about why I chose these 5 in particular. Number 1, which was estimate the sum to the nearest 1,000. Oh, that's the wrong one. It should be the one that says estimate the difference to the nearest 1,000. I cut and paste the wrong one, and it was 2,349,199 minus 982,733. What you would have to do here is, that's kind of embarrassing that I had the wrong one there, but they would have to round both of those numbers to the nearest 1,000, which, if you notice on H, was if they hadn't rounded it at all. G is if they rounded to the wrong place, and so is J. F is the correct answer at that point. But to model this, so if they need to review this at home, it rounds to that. And then when you subtract them, it does become the F is the correct response there. Biggest mistake that most of the class made here was they didn't estimate it. They just, strictly speaking, subtracted that. So that's the one big mistake here. On our second one, which I do have the correct one there, it says, according to the following pattern, what will be the 7th number? Just out of curiosity, what did you guys get?
A.
A. 24.
B.
B. B. Okay. If you go to the pattern is +3, so 21 would be the next number, but that's only the 6th number, and what they wanted was the 7th number. And that is the biggest mistake. I would say when we actually look at the breakdown, it's split pretty evenly between A and B, because a lot of students did find just the 6th number rather than the 7th number. Way to kind of get help your student get better at that is actually have them draw lines. So this would be 1, 2, 3, 4, 5, 6, 7. So they need to fill in as many underlines as they have. So it's just important for them to pick that out. It's great for them to pick out, the pattern, but they also do need to pick up that it's the 7th number, not just the next number. For the third one that we had, it was Jeremy had 50 raffle tickets to sell. He sells 7 tickets in one day and 16 tickets the next day. How many tickets does he have left to sell? I chose this one because it was a multi-step word problem, and he could have attacked it in a couple different ways. The way I personally did it was I did 50 minus 7, which would give me 43, and then subtracted an additional 16, which would give me 27. The other way you could have done it was you could have added 7 and 16, gotten 23, and then taken that away from 50, which would you'd still arrive at 27 either way. The way that they came up with some of those other answers, F, they came up with that by adding 16 and 7 and then adding that to 53. G was by taking away just the 7. H was by taking away just the 16 possibly and subtracting incorrectly on top of that. So it's always kind of interesting to kind of figure out where those answers came from, because that can help you kind of analyze what your child is doing wrong, because that's kind of what I do when I'm looking at your the student's benchmark, see how many of them interpreted the word problem incorrectly, how many of them added wrong, all that kind of stuff. The fourth one, which was the most missed question in the entire class, because it was
a horrible question.
It's worded very strangely.
Where are you getting your numbers from?
And it takes more work.
Yeah, it's just a lot of work. Basically, what they have to do is just solve all 4 of them and figure out which one is going to be between 50,000 and 500 or 55,000. It's a lot of work to come up with one answer. Even me, when I was doing
I
it.
was here the day they were doing the benchmark.
Well,
What?
I mean,
I
I
was
didn't
here
even
the
know
day
how
they were
to
doing the benchmark.
interpret the question
Yeah.
as the answer is
Yeah.
between this and this. I didn't even get that point. I sat there and figured out what the relationship was at the 2 ends and then rolled it into the next step.
And that's exactly a lot of the kids. It wasn't even so much as they didn't understand subtraction. It was they didn't understand, what am I supposed to do with this? So that's something that they had. A little backstory to Warren County. We just recently updated our benchmarks. So this is the first time I had ever seen the problem. So this, and I've already, they're going to see stuff like this in future future benchmarks, and possibly also the SOL. I can't speak, I don't work for the Department of Education, so I don't know what exactly is on the SOL. But all it basically means is solve all of them and then find which one falls in between that. The number line's kind of redundant by saying this too. That's kind of redundant by saying the number line. It's just an extra step for no real apparent reason, just very worded confusingly. We'll talk about that when I pull up the little spreadsheet of how the class did, but that is the one that was missed most commonly through the class, because that's kind of daunting to have, because the correct answer ends up being D. So they would have to do 4 subtraction problems, and that can be overwhelming to kids, which is kind of one of the biggest things when we get into the SOL is it's between 40 and 50 problems, which is a lot to have kids do, even over 2 days. That's just a lot to ask the kids to do, and especially when a lot of these problems are going to be, they're going to have to solve more than one thing to get to it. But hopefully we won't have to worry about the SOLs until the spring. It's not worrying about that now. But that is something we will talk about this more as a class, especially when we get to the benchmark or towards the end of the quarter, because I'm willing to bet on the benchmark they're going to have something like this, but for division and multiplication, because that's kind of our focus for this advisory. And then our last one, which was again one of the more commonly missed in the class. There was one difference on this was all the ones in multiple choice. This one wasn't open-ended, so they couldn't even kind of rely on an educated guess. They had to do something. This was a multi-step problem where they had to multiply and then add. One thing I saw a lot of students do, they saw 48, and they saw 3 times, so they did 48 times 3, which gives 164, which I saw a lot of students had 164 as their answer. But what it's saying is together. So that's 164 is just how much Nathan caught by himself. When you add that to 48, no, I lied, that's not 164. 144. Sorry. I have that written on my paper. I did the same thing before. So 144 plus 148 is 192. So I saw a lot of the students ended up with the 144. I was impressed that they recognized that they did have to do something about the multiplication, but it was the together thing. So if you notice, I picked those A because they were the most commonly missed questions in the class, and B because many of them were actually, all of them except for the first one, no, actually all of them were multi-step problems. You had to do more than just one thing. In the first one, you had to round and then subtract. Second one, you had to find the pattern and then do it twice. Third one, you had to either add and then subtract or subtract and then subtract. Third one, you had to subtract 3 times or 4 times and also interpret that. And the last one, you had to multiply and add. So a lot of different steps that they had to go into. If you felt overwhelmed with that, imagine how your 9 or 10-year-old son or daughter felt. And that was only 5 of the, I think they had 40 questions to do. So which will bring us to the actual going over the results. Paper that I gave you is your child's individual breakdown. What I have up here is the class's overall breakdown. For your child's one, if it says, on the column where it says total, if it's 100, that means that they had it correct. If it says 0, they have had it incorrect. And on the very, very bottom, the very lower right is their score for the benchmark. So if you see number 12 was the one we just did, which was our number 1, estimate the difference. I believe so. Number 13 was our number 2, which it was the pattern you see. It was exactly, most of the class chose 21. Well, some of the class did pick up on the 7, so that's something to recognize. That they picked up on the pattern is add 3. No one chose C, nobody chose D. So that tells me that we just need a little bit more work as a class. At least 62% of the class, and probably wouldn't benefit that other, or wouldn't hurt that other 38 to review it. That you need to really interpret not only finding the pattern, but also extending it. Number 27 was that one that I called the estimation bars. That's the one where, like you had said, it was just worded very strangely. You see 25% of the class, you see it all over the place. It's really hard to really see what exactly they did incorrectly there. And then number 40 was the multi-step multiplication and adding one, the Fireflies one. That one I don't have a breakdown of who answered 192, who answered 144, who answered 164 if you missed a beat, and all those different things, because that's an open-ended question, so I can either mark correct or incorrect. Overall, you see the skills that they struggle with are the ones that are in red. So right off the bat, estimation is most of the estimation, actually all the estimation ones are in red. For some reason, that is a skill that is kind of difficult to fourth graders. It has been the whole time I've been here. That could be because we spend a lot of time in class on the actual exact stuff and not as much time for the estimation, which is something good for me to recognize, so then we can restructure and do that. But that kind of stuff. Expanded form, if we look at number 3, expanded form is, the expanded form, how they do it in 3rd grade is different than how they do it in 4th grade. So that is a big changeover. In 3rd grade, they do like 400 plus 30 plus 2, versus for us, it's like 400 times 100 plus 3 times 10 plus 2 times 1. So that's always kind of a changeover. I will say that I have never seen, other than on the benchmarks, I've never seen on any of the stuff the Department of Education releases, any practice problems of the expanded form, so that's kind of a little silver lining there. Rounding, number 9, was, rounding is a skill they've been working on for the past couple of years. It's just determining the place is sometimes something that is a little tricky to them. You see a multi-step word problem at number 14. Anything that's multi-step is going to trip them up a lot, because in the lower grades, 3rd through lower down, it's a lot of single step problems, and then when we get to 4th grade, it's like a whole new ballgame. You have to do multiple things.
What's the W in?
Whole numbers. That's just code. I should have explained that. Yeah. Whole numbers. This is because in the past years, it used to, first advisory used to be whole numbers and decimals. So there wasn't a whole bunch of stuff here, but WN just means it was a problem with whole numbers. Any other questions about this? I'll leave it up there, so if you want to write down what.
So you show 1 through 20 there. What's 21 through 40?
Over here, I just had
Over on
to,
that,
yeah.
Okay.
I just had to split it to
I
fit
see.
it all on one screen. But
What's
yeah.
number 25?
Number 25 was a multiplication word problem.
What does it say for skill?
Multiplication word problem. 25,
Oh, I'm looking at, I guess it's number 27 then,
27.
the one in the red.
This one?
Uh-huh.
It's number 4 in here. Is this one? It's like estimation,
Okay.
with the bars.
So I have estimation, expanded form, rounding, and is there anything else?
Word problems is going to be, and the best way to use work to fix word problems, short of coming them up with yourself, is on IXL. The whole F category is word problems. I believe, if I'm remembering correctly, F4 will give them, it's going to be a mix of addition, subtraction, multiplication, division. So not only will they be practicing word problems, also have to practice when to use what operation. And we have done all 4 operations now. That would be a good one to start using now. I didn't want to introduce that one too early, because we hadn't done multiplication and division last time we had a math night. Any other questions? All right, so talking about our stuff for geometry, full disclosure, geometry is my absolute least favorite unit in the entire math unit. Mrs. Hamilton, the woman who was in the flip video with me on Monday night, I guess, that's actually how her and I met. I was in like a Twitter chat with a bunch of other teachers, and I just kind of went on a rant about how much I hate geometry, and she's like, why? And I was like, I just don't find it to be relevant. And that's how she kind of earned the name of the Nonagon lady, because she found a bunch of Nonagon things in real life. Well, there's not a bunch of things that are Nonagons in real life. Trust me, when we were trying to make the video, it was very hard to find Nonagons and heptagons. But a lot of the geometry stuff, I just personally don't care for. I do try to make it as fun as possible. I'll show you one of the centers that we'll be doing next week that you can actually create at your own home that will kind of help reinforce that. But to go over all the stuff, geometry, the first, geometry is kind of broken into 3 sections for me. It's all this overview stuff, then the polygons, and then congruence and transformations. So the first one is a point. That's literally just a point. The line is that it goes over in both directions forever and ever and ever and ever, which that's just a geometry thing. You're not going to see something in real life that goes on forever and ever and ever and ever and ever, unless you're talking about paperwork. then that might be a line. Line segment is just part of a line. It has a stop and a start point. One thing that kind of screws up students is a lot of times when we're drawing something, we say, draw a straight line. Technically speaking, they're drawing a line segment because you can't draw something that would go on forever and ever. So that is when we first start geometry, they kind of think that a line segment and a line is the same thing, which they're not. Endpoints are just the end of the line segment or the end of array. Array is part of a line, has one endpoint and it goes on forever. I like to think of that as like a ray of light, like a flashlight or a car headlight that starts at the bulb and actually does go on forever because light particles really don't stop. Apparently, that's what my physics teacher told me in high school. An angle are just two rays that share the same endpoint. The big thing for them is making sure about naming it, that the vertex, which is where the two rays meet, is always in the middle. If you're going to angle it, angle ABC or just angle B, the B is going to be important. It always has to be in the middle. The vertex always has to be in the middle. A vertex can also be where two lines intersect. Basically, vertex just means where two things meet or kind of cross each other. An example question that was from my former SOL, I don't remember exactly how many years ago. It says, which of the following represents point KL, or ray KL? It's this one because it's KL. What I would have liked, well, I wouldn't really like this, but what I think would have been a good challenging question would have, rather than this be a line segment, have K or LK, and then have the ray there to differentiate that a ray can go, it starts, when you're naming it, it starts at the endpoint and goes out, versus a line and line segment can kind of go both ways there. So that would be something to kind of check with your student if they understand the difference, why a ray has to start at one place and go in the other direction. So common mistakes, like I said, confusing a line and a line segment, that comes a lot from just their background knowledge in art, drawing, and pretty much anything. I mean, even when I tell them to draw a line on the paper, I don't say draw a line segment. I should, but I often forget. It's just kind of a weird thing to say. Confusing angle and ray because line and line segment are kind of related. Angle and ray are kind of related because an angle is just two rays. Even when I did the flip video, part one of it, line and line segment were on slide, or one slide, and angle and ray were on another. And not identifying and representing them correctly. What I mean by that is, especially with the ray, it might be the endpoints here and it goes that way, and it might be AB, but they might write ray BA. But generally speaking, when we've been doing the stuff in class, they are identifying what they are pretty well. It's actually one of our math stations we've been working on this week, and so on and so forth. So ways to practice this. IXL P29 will go over all that stuff. It'll show one and it'll say like, what is this? Or it'll say, choose the ray, and they have to choose the ray. They can actually use their body to model, so this could be a really quick check. We haven't done this in class yet, but we will soon enough. To model, a fist would just be an endpoint, and an open hand would be an arrow. So if you want them to use their bodies to show you a ray, it would look like this. This would be a line segment. This would be a line, and then this one would be an angle. That's one of the oh yeah words that we will work in there. Another way that Ms. Burt recommended to me last year, but we haven't done this because we're not allowed to use this kind of stuff in school, but it's neither here nor there. You can get those mini marshmallows and toothpicks, and the marshmallow would represent either a point, an endpoint, a vertex, and the toothpicks would represent the line as a line segment. So if you wanted to use that as a more hands-on way, give them a couple marshmallows, a couple toothpicks, and say make me a line segment. So they would have a toothpick, marshmallow on either side. They could make an angle. They could make a ray. They could really make any of this. Another thing that they can do, which is going to be our math centers for next week. Well, not next week, after Thanksgiving, but this is something you could make over Thanksgiving to kind of prepare them. It's a game that I made called Polygon Pizza, and all it is on the inside, it's a pizza box. It doesn't have to be Little Caesars, but any pizza box will do. On the one part of the box, there are, I believe, 25 different boxes, and it has everything. It has everything from points all the way up to the quadrilaterals. Everything down there, and then up here is basically just a crazy line drawing I made and identified the lines. Then if on the link, that Polygon Pizza link, it takes you to a flashcard page, which is the same website I use for the social studies flashcards. And if you start to return, it says which box shows point A. So then they have to look in the box endpoint A is in box number 8. So if they click on it to check themselves, it says box 8. And then they go to the next one, which box shows line AB or BA. So right here is line AB or BA. They click it, box 17, and it has 17 there. So it's a way that it's a game that they'll be playing after Thanksgiving, and it will just kind of self-correct it. You can make one at home really easily because that link to use this is in this presentation. It's also on my website under resources, under math. I don't know what letter it is off the top of my head, but you could kind of at home pull up the flashcards themselves and then kind of use the flashcards to work backwards to kind of grid it out yourself. I'll also leave this out if you want to take a picture of it on your way out, and then that might just be easier than try to work backwards. Feel free. But the kids last year really liked it. Biggest tip I can give you is reinforce the pizza box because a kid rolled over it on a yoga ball last year, and it was not fun. It was not a fun day for that. But that's a really good way because that is a very self-contained. It has everything that they will need for geometry in it. The Quizlet website works on any device, so you could, any internet device. So if you're driving around somewhere, you can give them a phone or a tablet, whatever, give them the pizza box, and they have to kind of, it's a good self-correcting way. Polygon pizza's going to pop up like 16 different times in this presentation. The next part is the intersecting lines. That's the intersecting, which is just simply they cross each other. The one point in common is a vertex because it has, it makes an angle there, makes an angle there. Perpendicular is just a special form of intersecting lines. It's going to form a right angle, which I told them to think of like a capital T. Doesn't necessarily have to be a capital T like this. It could be an X, just as long as you could put a perfect corner in there. We talk about right angles there, but we don't talk about the acute or obtuse angles. That's a 5th grade thing, but they have had right angles in lower grades. Parallel lines, they just never cross. They will always, always, always be the same distance apart. This is an example from the SOL, and it could also be a street map, but it's going to say identify 2 lines in the figure that appear to be parallel. And it's J and M, but a lot of the times what students in the past have picked are P and R because they're not touching right now, but because they are lines and they go on. If you extend this out and you extend this out, they eventually cross around somewhere in the 4. So that is why in the flip video this year, I made sure that I did make a point of that lines will go on. You might not see it, but always extend them out to make sure that they are, if you think they're parallel, that they are parallel, or check if they're intersecting. So that's one thing. Same thing, I've also had students in the past picked J and K, thinking because they're not touching right now, they do eventually touch there and there. Common mistakes, like I just said, I'm getting ahead of myself a lot here. Not extending the imaginary lines to make sure they don't cross, and mixing up intersecting perpendicular. By and large, they're not going to screw up parallel lines. What they will mix up is which is intersecting and which is perpendicular, because perpendicular is always intersecting, but intersecting isn't always perpendicular. So they just have some overlap. A lot of times they'll call perpendicular set of perpendicular lines just intersecting, and I'll say, well, what else is in there? Like, well, it's intersecting, they're crossing. But what else? And then they kind of flew into it there. So ways to practice this, IXL P30. Again, they can use their ARMS model. You can just have them go like this and like that, all that kind of stuff. When you're driving, you can just have them, when you get to an intersection, that'd be even a good conversation. Say, why is this called an intersection? Because it's called an intersection because they're intersecting lines. You can have them, if you're driving down a highway and there's divided highways, say, what is this highway and the next highway? What are we in relationship to? They're parallel, that kind of stuff. You can put down a pencil or a straw or any other straight object and question them, say, are these parallel, perpendicular? Good way to reinforce that imaginary line is get a sharpened pencil and put them so they're not currently overlapping, but checking that if they will overlap them. And the polygon feature, the upper portion, this line drawing, all the questions related to that are like which ones are perpendicular, which ones are parallel, which ones are intersecting. And there's even ones where it's like AB is intersecting with GH. So those are other ways to practice that. Transformations and congruence. To start first, I'm going to start from the bottom, kind of work up. Congruence just means that they're the same size and the same shape. They don't have to be in the same position. They don't have to be rotated the same. All they have to do is be the exact same size and shape. So that was, I think, last night's video. So that's actually the example I gave them this morning. It's funny, I didn't mean to do that. But I had them prove their work because on their morning work when they came in, I had two rectangles drawn, and the one was up and down, the other was side to side. I said, are these congruent? And they said yes. And I said, well, that one's on side. And they're like, well, it should be the position, doesn't matter. I was like, wow, you were listening really well yesterday. So then we have the reflection, the rotation, and the translation. The reflection, I like to think of that as just think about the mirror. You know, your reflection is the exact same thing. It's been flipped. If you like the underlining the FL and the FL and flip. So it's just exactly the mirror image. The rotation, I like to tie that into our science unit where we're talking about the Earth spinning. Basically, the rotation is just a turn. It's turning on a side. Occasionally, let me talk about translation. Translation is just when it is slid from one direction. It doesn't have to be straight over. It can be over and up or diagonal, but nothing's changed about it. It's just been slid to a different place. One thing that I like to do with my students last year, which we haven't gone into because tonight's video is about the transformations, is I would do multiple translations, and I would say figure out how I got there. So it would be like a rectangle that was up and down, and I put like a dot on the top, and then I would have them, and I'd have another one that was the dot was now on the bottom, and it was on its side, and they had to recognize that it was a rotation and a translation, possibly a reflection too. Sometimes I'd throw in all three. That's not necessarily something they have to do for the SOL, but it's a really good way to check their thinking levels if they can kind of trace the pattern. Some of them would trace the pattern, some of them would come up with ones for each other. So that's a good way that you can do. I don't know if I have it on here. So for examples for congruent, it says, this is one example. It's going to say which pair of figures appear to be congruent. And you see they are all kind of the same shape, but the only ones that are congruent are A and or just A because those two are congruent. It will always say appear to be congruent because they don't necessarily have to measure to make sure that they are exactly the same size. The kid actually did that this morning. I said, well, how do you know those are congruent? That one's on this side. She's like, well, Mr. B, pulled out this roller to measure it. I was like, awesome. That's not the answer I was expecting, but congruent, it's always going to say appear to be congruent. The other way congruent thing could be is it might have like one thing, or kind of like the bring back to school problem from yesterday. It was I had the one arrow and I said which one appeared to be congruent. And I had the three other arrows, two were blatantly not congruent, and the one was congruent, but just in a different position. They will have ones like that where it get from one original shape or polygon, and then they have to ask, they have to figure out which is congruent. It can be more than one, it could be multiple different ones. It says, and then here's for the transformations, which picture shows a single reflection of a figure across line R. A lot of students won't pick that, they'll realize that that's just a translation. But then they will get tripped up between this one and this one because they realize that it's not oriented different. It's been reflected, but then the shapes inside it have also been changed. So it's always important for them to look at not only just the polygon itself, but if there are different shapes or designs within it, that one has been rotated and translated. That's the only one that's actually been reflected because of the circle and the square within the hexagon. This one, they actually just moved the shapes within the hexagon. So that's something, if you're checking your student at home, don't just put a polygon with like a shape inside it, and then that's a way to check if it's a reflection or a translation. Because if this didn't have the shapes inside it, it could be a reflection, but it could also be a translation. It's hard to tell with a shape like that or a polygon like that because it looks the same whether you're sliding it or reflecting it. So common mistakes, just for forgetting what each one means, they might remember like the basic terms of flip, slide, and turn, but just kind of correlating that to the actual geometry terms and not looking at the symbols within the shapes like how I had just shown you with the hexagons. So ways to practice this. This was actually kind of hard to find when I was looking through IXL because IXL is aligned to the Common Core, which Virginia is not aligned to. So I kind of had to jump around on the site a little bit. But if you want to look at the transformations, you actually have to drop down to 3rd grade and then go to ARC 7. And if you want to practice, well, if your student wants to practice congruence, they can stay in the 4th grade section. It'll be P11. It will also say similar, which isn't something we cover in 4th grade, but similar just means that it is the same shape but a different size. But it'll say either which ones are congruent or which ones are similar, and that's similar to something else. You can use toys or cutouts. You could just make like cut out some different polygons and say, here's the original one, here's a new one. What have I done to it for transformations? And even on Polygon Pizza, there is like this whole row. All those ones are those are all different transformations that I did there. And I used to have a similar one on there too, just because I needed 25 things. So polygons are the last part of geometry. Polygon, like I told the students, is just a kind of a fancy word for shape. The only difference, things like circles and hearts are not polygon because they don't have straight lines in them. Triangle, 3 sides, they've grown up with triangles since probably preschool or kindergarten. Pentagon has 5 sides, which the way I help them remember that is just the federal building in the DC area. The hexagon has 6 sides, and the ones that they will mix up most are the hexagon and heptagon, because they know that they both start with H, and they're kind of newer ones. A student actually beat me to it this week on talking about the difference between the hexagon and heptagon. They said, well, Mr. B, hexagon has X in it, and 6 has X in it. And I was like, you stole my video for next week, but thank you for that. But that was really cool to see them kind of come up with it themselves. So that's how I have them differentiate. The other way I did get to teach them something was that I said heptagon has 5 letters, or hepta has 5 letters, 7 has 5 letters, so that's how I have them remember. Other way, 6 is less than 7, hex has less digits than hepta, just making sure they know that the hexa and hepta are different. Octagon, they're not going to mix that one up because they have seen subsigns all their lives, and octopus has 8 legs. The nonagon, hopefully with Ms. Hamilton joining me for the video, they will never forget a nonagon. That was actually one that my students wouldn't forget last year because we had done, she kind of interacted with her class last year through like voicemail and stuff. They know her as the nonagon lady, and she actually sent them all little nonagons around the SOL as good luck nonagons. It was kind of fun. Nonagon just sounds like 9. One student came in with their notes, and they were like, couldn't remember what nonagon was, and another kid was like, what does it sound like? And he's like, oh, okay, 9. So that's the easy way. And decagon, 10 sides, and just means that a decade has 10 years. That's how they remember that, especially since most of them are about a decade old. That's kind of a good way to clue them in. The other ones where they kind of get mixed up a little bit over quadrilaterals, and those are all the polygons that have 4 sides. They are very used to the first one, the rectangle and the square, because they have grown up with them. They aren't necessarily used to the actual geometry terms, where a rectangle just means it has 4 right angles. A square is a rectangle with 4 congruent sides. I kind of said it slightly different in the flip video, so what I say here is I tried to make it a little bit more kid-friendly in the flip video, so they're going to be slightly different from here. A trapezoid has one pair of parallel sides. A parallelogram has both sides of opposite sides parallel. And a rhombus has 4 congruent sides. Now, the thing that gets confusing is that other than a trapezoid, they all kind of can be each other. Like a square can be a rhombus, so is rectangle, so is parallelogram. They all kind of relate to each other, and that kind of turns them on their head a little bit. One thing they will not necessarily mess up the rectangle and the square, but these bottom 3, because they are new, are the ones that are a little bit more challenging. They will, especially the trapezoid and parallelogram, because they know both of them have something to do with the parallel sides. They can't always remember which one. I try to reinforce it by saying that, well, the one that has the word parallel in it is probably going to be the one that's going to have more parallel sides. The other thing is the trapezoid. They might see this one, kind of like the trapezoid tables, which we don't actually have in here. I have like every other shape table in here, except for trapezoid table. But the trapezoid table can also kind of look like, well, it's like a triangle with its side cut off, but it can also look like a right triangle with the top cut off. So really the bottom 3 are the ones where they mix up with the quadrilateral, of the quadrilaterals and try to remember like, well, I know the square can also be a parallelogram, but a parallelogram is not always a square, so on and so forth. So a lot of the times with polygons, it will not be the traditional representation, which is going to kind of what I tried to step away from on the flip video was like the star at the end. What normally when past years when we've been teaching decagons, I was like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But a star is a decagon because it filled in star. So a lot of students were like, I didn't know a star was a decagon, which I thought was kind of cool because I didn't know until Connie had brought it up to me. So what I'm saying about this is none of these ones, it says, which shows only octagons. So the arrow and that, what they have to do is actually count each side to make sure that it has 8 sides. They're not just looking for stop signs, or they're not looking for just traditional hexagons or that. So that will be kind of the video for one of the videos for next week is I'll have a bunch of non-traditional ones. I'll say, what do you think this is? Write it down with pen so you can't erase your work, just so I can see what you know that. The other one, another example question is it might have a description of polygon, and we'll say which are true for a rhombus or which are true for a hexagon, whatever it has. So you have to choose all the descriptors. So for a rhombus, there are exactly 4 sides. All sides must be congruent. There are more than 3 vertices. Both pairs of opposite sides must be parallel. Does not have to be at least one right angle, and the angles don't have to all be congruent. So they have to kind of think about that. Which one thing that I tell them, if it's going to give them a question like that, just simply draw yourself one of whatever it's asking for, and then use your little drawing to relate to the different descriptors. So common mistakes, not counting sides correctly. What I advise them to do, which I wasn't able to do in the video because we were recording it on my iPad, was physically put a slash through each side when they're counting. Just it kind of holds them accountable to make sure, especially if we go back to the little stair-looking thing. That's a lot of different sizes to count. And if they're just kind of going like 1, 2, I don't remember if I counted that one, they might kind of count. But if they're just putting slashes through the sides as they're going along, they won't forget it because it's a physical reminder. Confusing hexa and hepta, not confusing confusing all the quadrilaterals, mainly the bottom 3, like I had said, and not verifying all shapes or information. What I mean for that is if this one, if it says which set of figures shows only octagons, they might count, like if it's 2 of them, they might count one of them, see, oh, it's an octagon, and not even bother to count the second one. That is kind of just a 4th grader issue in general, where they just want to go, which something about rushing will come out at all of these evenings, because that is just something that they like to do, is go as fast as possible without really proving their work. And by and large, the students who do take their work outperform the other students, whether or not it's an ability thing. Like this, a lot of students who are done first and score poorly isn't necessarily because they didn't understand. They just didn't take their time. And then there are students who take 3 days to do different things, but then will end up with a really good score because they have proved each one painstakingly, often counting each side. I had one time, I had a question like this on an assessment, and I got it back from a kid, and I couldn't even see the polygon anymore. And I was like, what? It's like, what happened? She's like, well, I wasn't sure, so I wanted to go keep checking the sides. And I was like, by the 48th time, I would have said you're fine. Like, I literally, it was just all pencil lines. I couldn't see the polygons anymore. And I was like, good thing I have an answer key here, because I couldn't even like check it myself. But that's the kind of stuff I would prefer to see, is meticulous checking, just to make sure that they are doing their best. So ways to practice this. IXL, there's various different ones in the P. The P is the whole geometry section. 1, 6, and 9 will do different things with different polygons. P6 is going to give them some other polygons that they won't necessarily need to know for 4th grade, but it will get them a jump for 5th grade and other grades. I remember in past years, I want to say P6 it starts throwing in stuff about dodecagons, which are 12-sided figures, which is kind of fun to let IXL teach them that, when they kind of guess. One of them, I want to say IXL 9, will say, like, if you have 4 hexagons, how many sides do you have? So it's kind of doing a little geometry with a little bit of multiplication, which is always a good thing to blend two different scales. You can just have them, you can just get a whiteboard or a piece of paper or whatever writing implement you want and draw different shapes, make them non-traditional, like as long as it has the amount of sides, it's going to be one of those polygons, and just have them students identify, make them, cross out all the different sides, and then again, Polygon Pizza has all of those on there. So that brings us to the end of the evening. Any questions? Okay. Thank you for coming. Next, in December, it is another kind of weird month with all the holidays, and snow will probably pop up at some point too. I've just been reported saying that. But I do want to definitely get in at least one more to go over what will be on the math benchmark and the reading benchmark. I might just combine those both into one evening, just for the sake. I kind of have to look at my calendar and figure out when I'm going to be in the Roanoke for the conference and all that kind of stuff. But if you have nothing left, just make sure you fill out the little feedback slip on the bottom, or the left slide, and the